Assalamualaikum and hi doctor. I am Nabiha Inshira binti Mazli from course SJI. My matric number is J25A1239. We are from group 8B. Today, our group going to present about our water filter prototype. The first part is introduction. Clean and safe water is essential for our daily activities. However, many water sources contain dirt, sediment, and other impurities. Because of this, simple and effective filtration methods are needed to improve water quality. For problem statement, in some areas, people still face issue with cloudy or contaminated water. Without proper filtration, the water is not suitable for drinking or household use. This issue encourages us to create a basic water filter prototype that can remove visible and impurities. We choose this design because it is simple, affordable, and easy to build. The selected materials such as fine sand, coarse sand, small rocks, charcoal, sea coconuts, and clothes. We are choosing this because each layer plays a role in filtering the water.
Hello, I'm responsible for representing the material we use and the method we follow to construct our DIY water filter. This sample filter demonstrates how different material can remove various sizes of debris and sediment from water. To build our water filter, we need two main characters of materials. First, the container and the filtering media. The container, we use a simple plastic bottle. We cut off the bottom to act as an inlet for the dirty water and ensure the cap was secure. But with the small hole placed in it for the filter water to easy. Next, the filtering media. We collect 6 distinct layers of material. First, a small piece of sponge and cloth to act as a very base layer. Second, coconut husk, fine sand, coarse sand, charcoal, and small rock. The method involves carefully layering this material inside the bottle, starting from the bottom, which is the outlet, and moving up to the top, which is the inlet. This is crucial because we want the water to encounter the finest filter first and the coarse last. Step 1. The base. We first secure the cloth and sponges above the bottle cap. These layers prevent the finer sand from falling out. Step 2. The husk. We added a layer of coconut husk. This provides a light, fibrous base that helps trap particles and allow water to flow too. Step 3 and 4. The sand. Fine sand went in first, followed by a thicker layer of coarse sand. This dual layer is excellent for removing small and medium-sized sediments. Step 5. The purifier. We added a layer of charcoal. This positioned strategically to help absorb smaller impurities, color, and other. Step 6. The rough filter. Finally, at the very top, we place small rock. This large piece acts as the initial filter, catching the biggest piece of debris before they can clog the final layer below. And that completes the construction. By following this method, we create a layer column where gravity will pull the water through a passively filter.
Hi, my name is Nur Alia Batusha binti Ahmad Jais. My number matrix is J25A1780. So today, I will explain the data analysis for our water quality test. We have two sets of results, before and after treatment, and 3 different samples, Moscow, DAP, and Mentally Blue. So let's look at each water parameter one by one. So firstly, we have dissolved oxygen or DO. DO show how much oxygen is present in the water. For the Moscow sample, the DO slightly decreased from 94.2% to 91.5%. For BAP, the DO increased from 93.6% to 95.5%, showing improvement in oxygen level. For Mentally Blue, the DO dropped slightly from 94.3% to 93.2%. Overall, small change in the DO indicate how the water reacts during the treatment process. So secondly is turbidity. Turbidity measures how cloudy or clear the water is. A lower value means clear water. The Moscow sample improved the most, dropping from 33.7 to 25.7, meaning the water became clear. For BAP, turbidity increased from 10.3 to 22.4, showing the water became more cloudy. Mentally Blue also increased slightly from 5.26 to 6.67.
Assalamualaikum warahmatullahi wabarakatuh. My name is Roslinda binti Ismail and my metric J25A1693. Clear water is important for health and daily user. To check how effective the water treatment process is, we test 3 water samples, Moscow, BAP and Menthylene Blue. Before and after treatment, we look at 4 main parameters: dissolved oxygen, turbidity, total dissolved solid, and pH level. Those tests help us understand how the water quality changed and how each material affected the treatment process. Next, we move on the total dissolved solid or TDS. TDS tell us how many dissolved particles are present in the water. For the Moscow sample, the TDS increased from 5 to 430. For BBA, it's increased from 7 to 219, and for Menthylene Blue, the value rose from 13 to 110. There is an error in TDS reading. This usually happens when the sensor is dirty, the probe is not fully submerged, the water temperature is unstable, or the meter is not calibrated. Now, let's look at the pH level. pH show whether the water is acid or alkaline. The Moscow sample changed from pH 5.21 to 6.93, become closer to natural. BAP increased from 6.94 to 7.11, making it slightly alkaline. And Menthylene Blue went from 6.89 to 7.22, also become slightly alkaline. Finally, here is the overall conclusion. Dissolved oxygen show only small change. Turbidity become clear for the Moscow sample, but increased for BPA and Menthylene Blue. TDS increased in all 3 samples, and the pH value moved closer to natural and slightly alkaline after treatment. The results show that each material react differently and affect the water treatment process its own way.
In conclusion, this project successfully demonstrated how a simple water filter can improve the clarity and cleanliness of water using basic and low-cost materials. The combination of clothes, small rocks, coarse sand, fine sand, say coconut and charcoal effectively remove visible dirt and impurities from the water. The results shows that the filter water become clearer compared to the original sample, proving that each layer plays an important role in filtering process. Overall, this prototype is practical and efficient method for basic water purification.